Welcome back, everyone. Ready for another deep dive?
Definitely.
Today, we're going deep into the world of forests.
Yeah.
But not just looking at the trees.
Right.
Thinking about forests as these complex systems. Interconnected webs of life, really.
Absolutely. We'll be diving into Chapter 6 of the handbook, Roots of Complexity, a comprehensive guide to trees and forest ecosystems.
Oh, okay.
Focusing on sections 6.1 to 6.4, which talk about complex adaptive systems,
Okay.
emergent properties, network theory,
Right.
and even modeling forest dynamics.
Complex adaptive systems. I have to admit, that sounds kind of intimidating.
Yeah.
Where do we even start with something like that?
Well, let's just try to break it down. Think of a forest as this big puzzle,
Okay.
but the pieces are constantly moving and interacting, adapting.
Wow.
Each piece, the trees, the fungi, even the microorganisms, they all play a crucial role.
So it's not just a static picture.
Right.
It's like a dynamic process, always changing.
Yeah, exactly. And that's what makes it a complex adaptive system. You have diverse components, you have these intricate interactions like competition, symbiosis, feedback loops, where a change in one part can affect the whole system, and this incredible ability to adapt to changes in the environment.
So it's not enough to just look at one tree,
Right.
We need to look at the whole forest.
Yes, the whole interconnected web of life.
And when we do that, what happens?
Well, then we can start to see these amazing things called emergent properties, behaviors or patterns that come from all these interactions between the different parts.
Emergent properties. Okay, I need an example to understand this. What does that actually look like?
Well, think about biodiversity. A forest isn't just a random group of different species.
Right.
It's the result of this whole complex web of interactions, competition, symbiosis. All of those things create the amazing variety of life that we see.
So the biodiversity itself is like a product of the system.
Exactly. It emerges from the complexity.
That's so cool.
It is. Another example. Nutrient cycling. You've got this flow of nutrients moving through the system, from the soil to the trees, back to the soil when things decompose. It's an intricate dance involving trees, fungi, microbes, each one playing a part.
Yeah.
And this is the really interesting part, especially for you. These emergent properties have a huge impact on our lives. Like carbon sequestration, forests absorbing and storing all that carbon from the atmosphere.
Yeah. That's a big one, especially with everything going on with climate change.
Right. It's all those interactions between the trees and soil and the air.
Wow.
The whole forest ecosystem working together to make it happen. A single tree could never do that on its own. It's like the forests are these giant air filters, cleaning our air, helping to fight climate change.
It's pretty amazing when you think about it that way.
And that actually leads us to another fascinating thing about forests, how they're structured, like networks. Section 6.3 talks all about this, network theory, and how it applies to forest ecosystems.
Oh, okay. This reminds me of something I've heard about the Wood Wide Web.
Yeah.
Like this underground network of trees and fungi.
Oh, yeah.
I always thought it sounded a bit sci-fi.
I know, right? But the science is really solid.
Wow.
Network theory helps us to visualize it, analyze those connections, and it turns out they're way more expensive than we ever imagined.
So it's more than just trees standing next to each other. They're really linked together beneath the surface.
Exactly. Just like our cities have those intricate networks of roads and infrastructure, forests have their own hidden networks underground.
Okay, so tell me more about this Wood Wide Web then.
Yeah.
I'm really curious now.
Imagine this vast network of threads all woven together throughout the forest floor,
Okay.
connecting the roots of the trees in this intricate system.
Wow. And what are these threads exactly?
They're mycorrhizal fungi.
Mycorrhizal fungi.
Okay. These fungi form relationships with trees. They attach to their roots
Right.
and extend their reach throughout the soil.
So they're like a go-between for the trees.
Yeah, you could say that. Through these fungal networks, trees can share all sorts of things like nutrients, nitrogen, phosphorus, water, even carbon.
So it's not just about competition then.
Right, it's this incredible example of cooperation in nature.
It really changes how you think about the whole survival of the fittest thing. It's like they're supporting each other.
Exactly. And this mycorrhizal network, it lets trees share resources, send warning signals, even help younger trees grow.
It's like their own social network, helping them thrive as a community.
You got it.
That's incredible. I'm imagining these trees sending messages like, hey, need some nitrogen over here, or watch out, pests are coming.
Yeah. It's not quite like instant messaging. But the basic principles are similar. This network allows for this flow of information, resources that benefits the whole forest.
This is blowing my mind a little bit.
Yeah.
But how do scientists actually study these underground networks? I mean, you can't just dig up the whole forest floor, right?
Right, it's definitely tricky. Researchers have come up with some pretty ingenious ways to study those hidden interactions.
Oh, okay. Like what?
One way is using isotopic tracers. They inject a harmless isotope into a tree,
Okay.
and then they track how it moves through the mycorrhizal network.
So it's like tagging a package and seeing where it ends up.
That's a great way to put it. By tracking the movement of the isotopes, scientists can map those connections between the trees
Oh, wow.
and understand how the resources are flowing. They're basically creating maps of the forest's underground internet.
This makes me think about the mother trees we talked about earlier. Where do they fit into all of this?
Ah, yes. Mother trees are crucial to these networks. Those are the biggest, oldest trees in the forest. Think of them like central hubs, the grandmothers of the forest. They have tons of mycorrhizal connections, and they can actually channel resources to seedlings that need them, especially their own offspring.
So it is like a family thing, with the mother tree looking after her kids.
In a way, yeah, mother trees are these central nodes in the network. They facilitate the flow of everything. Resources, information. They can even send out warnings about threats like pests or drought.
So they're like the wise elders protecting the next generation. Makes you think about what happens with deforestation, right? What if we lose those mother trees?
That's a huge point. Removing them can disrupt the whole ecosystem. It's not just about losing a big tree, it's about disrupting those relationships that hold the whole forest together.
Like pulling a vital part out of a communication network.
Exactly. The consequences can be massive.
So protecting mother trees isn't just about saving one tree. It's about protecting that whole web of life.
Yes, it's about understanding that interconnectedness, recognizing that's what makes a forest truly thrive.
This has been so eye-opening. But wow, we've covered a lot.
I know, right?
Maybe we should take a minute to just recap what we've talked about.
Yeah, that's a good idea.
We started with these complex adaptive systems, the idea that forests are dynamic and interconnected.
Right. Always adapting to changes.
Then we explored those fascinating emergent properties, the characteristics that come from the interactions within the system, like biodiversity, nutrient cycling, carbon sequestration.
All of that emphasizing how complex and interconnected forests truly are.
Yeah. And then we went deep into this wood wide web, those mycorrhizal networks connecting trees underground, allowing for communication and resource sharing, and of course, the vital role of mother trees in all of this.
It's a perspective that challenges how we've traditionally thought about forests.
Absolutely. And it highlights how important it is to manage and conserve them in a more holistic way.
For sure.
Which brings us to the last piece of the puzzle here, section 6.4, about modeling and simulating these complex forest dynamics.
Yeah.
How can scientists actually predict how forests will respond to changes like climate change or deforestation? It seems almost impossible with all the factors involved.
It's definitely a huge challenge, but scientists have developed these sophisticated tools to model and simulate those complex systems.
Okay.
They use computer models to basically create virtual forests. Wow.
Where they can change different variables and see how the forest reacts.
So they're building virtual forests to help them understand the real ones.
Exactly. There are all these different types of models, each with its own strengths and weaknesses. Some focus on specific processes like tree growth or nutrient cycling,
Okay.
while others try to simulate all the different parts interacting together.
So it's like they can run simulations,
Yeah.
test out different scenarios, and see what happens. It's like having a crystal ball for forest management.
You could say that. Modeling lets scientists explore what-if scenarios.
I see. So like imagine you're managing a forest, trying to make it more resilient to climate change. You could use these models to try out different approaches virtually.
Exactly. Things like planting drought-tolerant trees or thinning the forest to reduce fire risk.
So instead of just guessing, you can test things out and see what happens.
Right. It's a really powerful tool for making better decisions. Decisions that benefit both the forest and the people who depend on it. I can see how useful that would be. But still, it kind of feels like we're stepping into the control room of a spaceship or something.
Yeah. All these screens and data, trying to get a glimpse into the future of the forest.
Exactly. But these models, they're just simplifications.
Right. They can give us really valuable insights, but they're not perfect predictions.
So it's more about using them as a guide,
Yeah.
not as like The absolute truth.
Yeah,
Yeah.
exactly. And that's where the expertise of the people managing the forests comes in.
Right.
Scientists, forest managers, they use their knowledge and experience to interpret the results and make good decisions.
It's really interesting, this whole intersection of ecology and computer science.
It is. And it's always evolving as we learn more about forests and as our technology gets better.
So we've covered a lot in this deep dive into forest complexity. Complex adaptive systems, network theory, modeling. It's incredible how much we're learning about these ecosystems.
And we're only just beginning to understand it all. There's still so much to discover about how forests work.
It makes you wonder about the future of forests, with all the challenges they face.
Yeah.
Climate change, deforestation, pollution. How can we use all of this knowledge to make sure they survive?
That's the big question. I think the answer lies in changing how we view forests. Instead of seeing them as just sources of timber or land to be cleared, we need to see them as these vital, interconnected systems that are essential to the whole planet.
So it's about seeing the forest for the trees, but also seeing those trees as part of this much bigger web of life.
Exactly. And that shift in perspective can be really powerful. It means understanding that even small actions can have a big impact on the whole ecosystem.
Like that butterfly effect idea.
Exactly. A tiny change in one place can lead to huge changes somewhere else.
That's why it's so important to teach people about this, right?
Absolutely. We need to educate the next generation about how important forests are, about these mycorrhizal networks, the wisdom of mother trees.
I love that, the wisdom of mother trees. It really gets to the heart of what we've been talking about.
It does. It reminds us that forests are more than just resources for us to use. They're ancient, complex systems that deserve our respect and protection.
This deep dive has been really inspiring. It's made me realize that forests aren't just trees. They're these incredible webs of life, complex systems that are so important to our planet.
And it's a reminder that we're all connected to those systems in a very real way. What we do to the forests, we ultimately do to ourselves.
So as we wrap up, what's the one thing you hope listeners will take away from this?
I hope they'll come away with a deeper appreciation for the complexity and wonder of forests. And maybe they'll feel inspired to learn more, to explore the forests in their own communities, and to speak up for their protection.
That's a great takeaway. And on that note, I think we'll leave you with this thought. Forests are more than just trees. They're intricate ecosystems, complex systems that hold the key to a healthy planet. Let's treat them with the respect and wonder they deserve.